Hello, stats students. This is lab number 2. Remember, if you did not complete lab number 1 last time, you'll want to do that today. So that has problems A, B, and C. Make sure you get all those done. And remember, there are lecture videos, or I should say lab videos, working through those problems if you have any questions. Okay, so in front of you, I have lab 2. It looks tantalizing, doesn't it? The first problem is a frequency table. I've started it off here for you. Remember, with the frequency table, you're just going to take the most common score. Sorry, not the most common score. The lowest score, like 2, and then go up from there. So 2 had 1 occurrence, and then I'm going to go 3 had 0 occurrence, and 4 would go next, and then you would have a 2 there, etc. All right, then you would calculate the mode, the mean, and the median, and you would sketch a histogram by hand. That is how to do that is in the lecture PowerPoints, if you've forgotten. All right, when you go to SPSS, do not try to input the table that you just made by hand. SPSS is not looking for a frequency table. It's looking for the raw scores. So in other words, it's looking for you to take these values and then just type them in a column. So it would go 2, 4, 4, 5, etc. And that's how you would do, and then go ahead and run the things you need to get the mean, median, and mode. Hint, it's going to be the frequency procedure. All right, then down below here, you need to look at these different distributions and be able to determine questions about the central tendency and the variability. So just a hint, the farther to the right you go, the larger the central tendency. So just for an example, B here has a mean of 3.5, which you might realize is larger than a mean of 3, which is what A shows. Do not be confused by the height of the distribution and think that represents having a higher mean. In fact, the height suggests what? That the variability is lower. The scores are more tightly packed around the mean. So a spike here means low variability. The flatter it gets, the higher the variability. So just to walk you through the variability issue, here we have variability from 3 to 4, roughly, if you just picking a point there consistently on the graph. And over here, if I pick that same point on the graph, it's going from 1.25 to 3.75, something like that. So this has more variability than this. You'll notice it's also flatter, another hint. So work through these. Some of these may be tied, so don't panic if you can't choose between two of them. All right, that is part 1. Part 2, which might be out of order, but you're smart people, you'll figure that out, is just working some additional standard deviation problems. You will recall that you have at least 2 things that would be helpful with that. One, you have a page in your toolbox, which should be around toolbox page 22, that where I work through the different kinds of standard deviation problems that I might give you. And then you also have near the front of the your course pack in toolbox page 1, I believe, the formulas. And so you have sum of squares here, sum of squares computational here, and then the standard deviation formulas. But I think you might find that first sheet more helpful. Okay, and then and the answers are down here. So when you work these, you can check and make sure that you got the correct answer. All right, and then let me scoot on down to this portion, part 3. Here what we're doing is trying to give you a playground where you can get a feel for what treatment effect looks like and what sampling error looks like. So question 1 asks you to imagine a mentoring program that we hope will raise college GPA for the students involved. If GPA goes up because of the mentoring, we would call that a treatment effect. And we're going to here compare the distribution of those in the mentoring to those in the control group that got nothing. So if we assume that the mentoring works and assume it's telling you here in 1A that it produces an average GPA of 2.5, that means that you're going to have a center of the second distribution here on 2.5, and if it has the same variability, in other words, same shape, it's going to be like that, and then you would label the difference between these two the treatment effect. So in other words, the treatment effect is equal to 0.5. I'm going to scoot on down to the key to show you that. So if you look at the first problem here, if you assume the mentoring works, that means there's a treatment effect of 0.5, and that curve has shifted to the right. GPA scores have gone up. I also want you to get an intuitive feel for the kind of scores you'd be likely to see if you were sampling from this second distribution. And you can see here that the scores that I'm suggesting you get would be like 2.3, which would be about here. Actually, let me turn on the little doohickey here. So 2.3 would be about there. 2.5 you would get here. 2.7 you would get here. 2.3 you would get there. Maybe you would get a 2.7 out here, but they're all going to come from this kind of part of distribution, the center part of this distribution. And you shouldn't be surprised if the scores are lower than what you would get over here from the control group. That's the whole point. You should be seeing higher scores, and when you get the mean of those, that mean should fall to the right of the control group. And then you can imagine if the treatment effect is even stronger, the curve shifts farther to the right, and you would get even larger GPA scores relative to the 2.0 that we would expect from the control group. All right, so in this first page, you got a positive treatment effect. In the second page, we imagine a treatment effect that has a deleterious impact. In other words, it decreases GPA. So I imagine people working and not having time to study. Then the treatment effect is going to show a shift to the left where you're going to have lower GPA. Okay, so give this part of the lab your best shot. This one might require a little more explanation, but we'll go over it in lecture. And we will do that the next time we meet. I think that is it.